Hi, my name is Ray Ryan. I'm with Square, and I'm here to talk to you about how our app got too big, and what we're doing about that, both in terms of the software engineering and also in terms of the social engineering required to give ourselves permission to do something as crazy as rework our entire massive app. I've been through these slides once with my wife. She didn't understand them. It went too long. I've added more slides since then, so we'll see how it goes. So let's just jump into the way things are today, the way our app works at the moment. It's a pattern that we call, or actually we don't call, I made it up for this presentation, key-based MVP. It's probably not terribly different than a lot of your apps work. We don't use fragments. We're notorious for that. Instead of that, we use a library called Flow, but the concepts are pretty similar. For each screen of our app, for each state of our app, there is a key. There is a name, a little value object, like a URL for a web-based app. And when we want to navigate through our system, we call this method called flow.set, which tells it this is the thing I think we should be showing right now. We have each key associated with a layout file that gets inflated. The layout file gets its hands on a presenter. The view and the presenter attached to each other. The presenter pulls in the appropriate model objects, and it's all the kind of MVP thing that you've all seen before. In concrete terms, if I'm looking at the cart screen, which you would do a lot in a commerce app like ours, I'm going to inflate the cart view. It's going to tie to the cart presenter, and the library objects might be, or the model objects might be an item library to pull things out that we sell, add them into a cart while we build our order, and so on. Comes time to navigate, we make a call to Flow to set ourselves to the charge screen. It's going to push that onto the backstack for us, and then we'll navigate to the next place that maybe take a charge screen, pull in a different view, different presenter, different model objects. All pretty vanilla stuff. There are warts with this. It's a nice modular style we're all comfortable with, but one thing that's not so nice is the circular relationship between the view and the presenter. It can lead to kind of awkward conversations, like the presenter saying, "Hey view, what are you showing in terms of money right now?" And the view asking the presenter back, "I don't know, what kind of currency do you think I should be using?" And then that can go back and forth, and it gets a little ridiculous, but it's manageable. We also have this dependency between the cart screen and the charge screen. They know about one another. The cart needs to know to navigate to the charge screen, and the charge in turn brings in its view and its presenter. We get some dependency tendrils trickling along there. And that can get even more so. Let's walk through the navigation of our app in general. I go from the cart screen to the charge screen. After the charge screen, I might want to tip my barista, and then I'm going to have to sign for the credit card payment. But on the other hand, maybe I'm talking to a plumber, somebody who doesn't get a tip, in which case I'm probably going to skip the tip screen, go straight to the signature screen. Anyway, from the signature screen, we go on to the receipt screen. And except, of course, sometimes we skip the signature screen because some payments are too cheap to bother signing for. And really, the charge screen should need to know about whether to make that step or not, because we might have skipped the tip screen as well. And all of these things need to know how to get back to the cart screen in case we cancel the payment. In a very small set of screens here, we've already got a bit more ridiculous navigation than we should really want to deal with. This is not hard to recover from. We tend to gather up that kind of flow concern into something we'll call a runner object, and that gets things back under control again when we remember to use it. But the cart screen also sometimes wants to go to the settings screen, which is a different concern, and there wasn't really worth bothering to make a runner object for that. And so on. So we've got some navigation sprawl going on there. We've got another kind of ugly point where this navigation type of logic can get intertwined with the related business logic. So let's go back to the charge screen, and maybe our card reader model object let us know that a credit card was swiped, and my presenter says, "I know what to do with that. I'm going to tell the nice tidy bill model object that there's some card info for it. And then I'm going to tell this payment runner object that cleaned everything up that we're ready to see the next screen. And maybe I should show the tip screen, maybe I should show the signature screen, maybe neither one makes sense in this case, in which case the payment runner itself will make the next business logic call. "Hey Bill, we're done now." So was I good about making sure that all of these types of business calls happen from the runner? Probably not. So the presenter sometimes talks to the bill, the runner sometimes talks to the bill, maybe the tip and signature screens talk to it. Things kind of get scattered about the app. And then one more kind of common painful case is reuse. How do we take a set of screens that work in one place in the app and make them work in several other parts of the app. Like, for example, when I'm building a cart, sometimes I want to associate a customer with it. So I'll start off my nice customer flow, and that'll bring up a nice pick customer screen for me. We'll choose the customer, and we'll let our model object know, hey, I've got a customer for you. Well, I've just learned from my product manager that we also need to be able to associate customers with receipts. Sometimes for the loyalty program, we've got to do that same set of steps. So I just want to be able to reuse that. I start up my flow again. I bring in my pick customer screen. I pick my customer again. And where do I put it? When I wrote this thing, all I had to do was add it to a cart, but now in some contexts I have to add it to a receipt. I could probably have parameterized that pick customer screen so it knows to tell the runner, oh, you're targeting the cart, you're targeting the receipt today. But that's kind of ugly. You know, I'm getting knowledge of all these various targets into the presenter. I can maybe create a kind of return value mechanism, kind of sneak stuff into my little key object that I was talking about, but it's supposed to be a value object. I might archive it to the bundle. I probably don't want it pointing at an actual live model object. If I was using fragments for some reason, this is similar to the problem that gets solved by fragment return value or activity return value. Do I really want my presenters to be communicating to each other through some kind of Android view-specific mechanism like that? That was kind of defeating the purpose of using presenters in the first place. Maybe I'll just have the customer runner itself hold on to the object that it picked, and then the presenter that kicked it off in the first place, whenever it starts up, has to know to look there to pull the thing out. That's livable. That's kind of what we do, except what we actually do is even more complicated. But, you know, it's rough, it's awkward, but we kind of get the job done. We've been doing this stuff with warts for years now. We're at the point where almost 200 people have touched the code, which is shocking. There's about 300 screens in this thing, which is even more shocking. It ships every 2 weeks, and people still seem to be using it. So we probably pulled it off. So we advanced 4 years with these practices, and there are bits of it that we really haven't pulled off. About 6 months ago, we had a bit of a meltdown where we realized that our clean builds were taking 12 minutes on a good day. It's still the case that a number of people are facing 2 to 4 minute rebuilds as they try to touch things. We kind of found ourselves in a tragedy of the commons with a sort of pasta-related theme to it. And meanwhile, related to us, our friends on the iOS side had an even worse life, where we have presenters full of concerns that really probably belong somewhere else, but the presenters are awfully convenient. They have view controllers, which have the nice property of being something that Apple gave them, but have the unfortunate property of being even more intimately tied to the view system. And there's this kind of what would Apple do derangement syndrome that they've been dealing with, where static singletons are kind of an encouraged practice that they have all since learned to hate, but oh God, now it's too late. Core data was a great way to start, but now core data has bled into public APIs all over the place. We've got undiffable zib and storyboard files. They have a habit of looking over to the Android team saying, God, those guys really have it together. And meanwhile, the Android developers are thinking, oh my God, the house is on fire. So we got ourselves in a situation where everybody's afraid to touch anything. We've got 2 apps with almost 800,000 lines of code, 300 frickin' screens. Nearly half of those are just in the payment flow, which was also, how does this happen when I take a short credit card and I do a signature? I don't want to talk about it. We have a culture that has been very skeptical of the role of architect, somebody whose job it is to step back and be in charge of these things. When architectural stuff has happened, it's because somebody's been frustrated and has made a grassroots effort, led a grassroots effort, or put in a heroic weekend or something like that. That doesn't work anymore. We've had several attempts to sit down and I'm going to fix the payment flow, and they have foundered off onto the rocks, whether they were brave volunteers or even things that got scheduled with management approval and everything. We're kind of in a bad way. So we actually decided to sit down and fix this on purpose. We founded a team called the Futures Team, and our job was basically to make it better and actually to be allowed to succeed at making it better. So this kind of a project is always a scary thing for the obvious reasons. So you're in a big, fast-moving operation. You can't just sit down and rewrite it unless you're Uber. Which was cool. I mean, I'm very envious. The way we decided to tackle this was, first of all, we didn't just jump in, roll up our sleeves, and fix all the obvious things. Because if the obvious things were that obvious, we would have fixed them by now. We tried, it doesn't work anymore. Our very wise director told us to sit back and spend a week or two around whiteboards explaining to each other what exactly the problems really were. And we go around and we talk to people and we gather things. We get a pretty clear notion of what's wrong concretely. And then we kind of sit down and fantasize about what would we like this to be like 2 years from now. When I sit down at my desk, what should my day be like? What should the software be like? What are the characteristics of that? And then from that vision, let's work backward and make ourselves a plan to actually get there from here today. 2 years sounds like a kind of arbitrary and specific value number. It was actually chosen pretty carefully. So 2 years is just long enough that you can imagine just getting anything done. It's all possible in 2 years. And it's a short enough amount of time that you realize, Jesus Christ, I can get anything done in that time. How are we going to actually do any of this? Kind of keeps you grounded in reality, but also keeps you suitably ambitious. That 2 years is also serves as an expiration date for our team. At the end of 2 years, we won't exist anymore. So we're not motivated just to fix everything right now and then make sure that we'll still be around to keep on fixing things as it goes on. We are motivated to fix things and try to fix them in a style that will keep itself fixed. Try to find new habits and new patterns that will kind of lead people to accidentally write things in a cleaner way and not just make the mess again as soon as we clean it up. So the specific problems that we kind of distilled everything down to these were the three major themes. The edit, compile, debug loop for both sets of developers was too slow, especially for the poor Android team. The code is too complex when I try to do anything about it. Yes, it's nice that it's all broken into these little modules, but the little modules have these intricate relationships. They're all too interconnected with each other. I can't work on this thing in isolation because it accidentally knows about these 5 other things and knows about these 20 other things. The thing that you do about that is obvious to everybody in this room. You modularize it. But how do you modularize it? It is not always such an obvious thing. I mean, the why you do it is, I'm not going to read the whole slide. It just says modularize 3 times. And particularly challenging is how do you modularize UI? How do you set up a set of related screens such that I can run them in isolation and develop on them real fast without having to boot up my whole app, and so that I can maybe reuse these 5 screens in this part of the app and that part of the app and the other part of the app while still having a consistent theme and feel across the app and not finding myself so incredibly siloed between these unrelated sets of screens that when design tells me that the 5th screen of the payment flow occasionally needs to be able to jump straight to the 3rd screen of the onboarding flow, which is true, I still need to be able to say yes to that kind of thing. So those are the problems we set to solve, and then the next step is to define that utopian period 2 years from now when all of those problems will be solved. So we visited the future and we came back with the architecture manual that we imagined that we would have, or at any rate we wrote the table of contents for that manual, and that kind of set out a vision for us to march toward. We didn't have to be especially perfect in that vision. We were probably going to wind up somewhere other than what we were really shooting for, but it gives us kind of something to aim at, something to be communicating to people as here's what we're actually after. We didn't spend a whole lot of time on this whole introspection and whiteboarding and problems prototyping phase. It was kind of December minus the holidays, but it was useful, and we came out with something more opinionated than we expected to. So page 1 of that manual, the core principles here of code that you can stand to work in at this scale. We just take immutability as a given. I probably don't need to stress that too hard. You've been here all week and people have been saying variations of this. Any object that crosses API boundaries should not be changing out from under you. We don't pass a live object out with properties on it that can shift, or God forbid, properties that you can accidentally change and then just destroy everybody else who's using that same shared object. Any kind of shared API should be a reactive API. That maybe means RX Java. It probably means RX Java on Android. It doesn't necessarily. Reactive is a pattern. It's not a library, and it's basically a push, don't pull mentality. I can push values in. I can ask to be alerted when values are available or have changed, but never, ever, ever do I call and pull and get a value out of something. We need to have not just a separation of UI and business concerns, but we need to have a natural self-sustaining separation of these concerns so that the natural accidental thing, obvious thing to do is also going to be the thing that leads us to write stuff in a style that keeps them from getting entangled again. And on an app that's meant to be identical on Android and iOS, where every divergence between those two is an accident, we would hope that we're going to see a uniformity of API across these platforms, across the modules that build up these things. So when I say uniformity, that means I mean code sharing? Maybe, sometimes, probably not. We want to make sure that code sharing is possible. We don't want to do anything that's going to get in the way of using J2obc or some other crafty thing. But there's no way on earth we're going to get our entire company to sit down and write everything in Java from now on and then spin it up to cross-compile to iOS and have our Android developers do it competently, have our iOS developers not quit. It's silly. There are great problems to be solved that way, but code sharing is just definitely not a panacea. We tend to think of it as, boy, why am I writing this code twice? I'm doing twice as much work as I need to. But really, the writing it is the easy part. What's going to take all of your time is maintaining it and debugging it. And especially if you're the poor bastard who's trying to maintain that code that came in from some other platform. Android developers love J2obc because, look, it's Java. Why wouldn't everything be Java? And I can just debug straight into it. Over on iOS land, I'm trying to debug into that generated Objective-C. It's probably cleaner than I expected it to be, considering what I was expecting. But it's still something that was generated. It's got a different build set up, and I probably downloaded it from some Maven repository somewhere, or God knows how it came in there. There's a cost, there's a friction. If you use something other than J2obc, like native C or React or that cool thing from Google whose name I forgot, Flutter, that we'll be learning about this afternoon, then that's foreign to everybody. So at least that's egalitarian, but it's still another source of friction. So there's a cost-benefit trade-off, and if the cost is high enough, for example, our tax calculation code, where it's really important not to have inconsistent results between the two platforms, then one of these penalties is probably worth paying. But there's also alternatives. Shared testing, for example. We have a system where we've got a bunch of JSON files that are shared that describe test inputs and expected outputs, and we rewrote the code to run them on a couple of platforms, but they can assure consistency of parallel implementations. There's shared API definitions. Have you ever used protocol buffers? You probably have. Well, that's shared code, and that's a way to ensure that things are uniform across the way. Anyway, enough on that. But the main point is this. Writing is easy. Maintenance is forever. Okay, so that's enough process talk. Let us get back to exciting boxes and lines. The two metaphors that we settled on, the two patterns for achieving this modularity of business code and of UI code are called workflows and bricks. We build a foundation of bricks, which are basically our business objects. They take care of the business logic. They're responsible for any I/O, whether to the file system or to the services. We have a layer of workflows on top of that, and that's where our actual app logic and UI modeling happens. And then turning all of that workflow stuff into things that you can actually see and touch. We've got the single container at the top of our app and a view factory providing it with things that it can show to the users. An interesting thing about these layers is that the first two are, or at least can be, asterisks, platform neutral. There's nothing particularly Android specific about this or even mobile app specific about this. If you want to write your bricks and your workflows and write them properly, there's no reason you can't run them from the command line. You want to do some load testing? Go for it. We've got prototypes that do it nicely. So talking about those layers from the bottom up, brick isn't a word that we actually use internally. We actually call them something that rhymes with schmigo. It didn't seem wise to feature that term, trademark term, so prominently in a talk, so it's brick for today. We wanted a neutral term like that. It got there. We wanted a neutral term like that because component and module and library and bean and anything else we could think of all mean something already. They're too freighted. We just want, the thing that you can build other things out of. That's how you kind of reuse chunks of code. The rules for this, and this is a pattern we're talking about. This is not a library. This is not a workflow, a life cycle. This is just a couple of rules to follow when creating an API to be reused across services. So this is our push-pull thing and our immutability thing all at once. I can set immutable value objects on a Lego, and Lego can report its state through an observable of some other type of thing, but these are pure value objects that are getting pushed in there. That could be protocol buffers, properly immutable protocol buffers, courtesy Wired. They could be Kotlin data classes. Swift has a fancy copy on write value, pass by value mechanism that could work serve for that. But there's nothing that's going to actually change going across the wire. And what they definitely don't have, again, are any of those dreaded imperative get value things. We write UI apps. They pull data from the file system, which we can't block the main thread to read. They receive information from a service somewhere. Everything always comes in asynchronously. So just acknowledge that fact and be comfortable with it in all of your APIs. Again, a drum I don't have to bang. We've all learned about RxJava. This is why. But whether you're using RxJava or not, it has to be observed at all boundaries. Now, if you turn a brick over and you see in the bottom there, you've got all these little columns and spaces and everything. That's where the any I/O happens. That's where any service stuff type of things happen. Any customer of a particular brick isn't dealing with that or having any knowledge of where things are being stored or where they're coming from. It could be here, it could be there, it could be layered. Doesn't matter. It's behind the facade. Building that reactive API is going to be easiest if you're actually using reactive fundamentals beneath that. Retrofit is quite good at that. SQLBrite and SQLDelight are a nice way to do that on a database. If you are going the J2 obc route, those both have the nice property of actually transpiling very well. If you're just building something for local use, Rx preferences or rooms are fantastic tools as well. A nice property about using the bricks pattern is that you can build big bricks from small bricks. When you do that, it's important that you don't let the smaller bricks leak through from the outside. This should just look like another brick that obeys the same rules. So it's got the same values in and values out API, and how it happens to be implemented is nobody's business. And if one or two of those bricks are implemented in some kind of crafty shared code style, points to you, but it doesn't matter. It's your little secret. There's no reason anybody should have to be aware of that. So dive into code. How are we on time? Not bad. Dive into code a little bit, what a brick might actually look like, or at least the API for a brick. Suppose we're putting together something that runs tic-tac-toe games. It's going to have a few enums to express how things work. Where are we in the play, and how do we mark our squares? Who's playing this game? And we can snap all that together into a state of the game at this particular point in time. This is a totally immutable object that is everything I need to know in order to actually understand a tic-tac-toe game. And the runner API is, again, going to be pretty obvious. I'd like to have a new game, or I'd like to restore a game. I'd like to take a square, please. As each of these things are happening, I can subscribe to this last little operation here, game state on the bottom, and that will be updating, giving me new pictures of how the game is running. One pro tip here, if you're using RxJava, life is best if people who subscribe to that observable don't feel obligated to say, I want to observe on the main thread, just in case I'm going to specify that every time I call anything. When you do that, it turns out you're introducing asynchronousness that you didn't actually intend to. You dig into under the wrappers, and there's a little call to post all over the place, and stuff that could have been synchronous and easy to debug is going to be kind of non-deterministic. An easy way to enforce that kind of contract is to just blow up whenever somebody pushes in a value from an unexpected thread. This is probably more detail than is warranted. I've given that detail before. It's online at that speaker deck. Don't worry about taking a picture of the screen. I'll put the URLs up at the end. Anyway, those are our bricks. Bricks are pretty simple. Now let's look at this workflow thing. What is it? Why is it? Well, remember what I was talking about at the beginning. We have these presenters and we have these runners, and the concerns from one kind of leak into the other. We've got the circular relationship between view and presenter. We've got the business logic, sometimes coming from presenter land, sometimes from runner land, sometimes scattered across 5 different presenters. Everybody's navigating promiscuously. There's nothing different about these things, the concerns that they have, except one of them gets to own a view and the other one doesn't. So why do we have this one-to-one relationship between presenter and view? And isn't one-to-one usually a sign that something went badly wrong? Why can't we have a single presenter using as many particular screens as it wants to in order to have more complete control over the particular task that it's good at? Rather than forcing developers to follow a thread through lots of class files. So a workflow is basically a presenter-like object that has an ability to put us through several screens at once. So its basic API It's kind of a one-shot deal. It's something with a start button. Maybe we pass it a value on the start, and it'll chug along and do some work for us, and then it will end eventually, possibly producing a result. So a login flow might start by putting up a few screens and then finish with, hey, here's an auth token that you can now use to kick off work on some other workflow. While the workflow is getting between points A and B, the start method and the eventual result, it's producing observables of these things called work screens, or workflow screens. Each workflow screen is exactly as much information as you need in order to render a particular view. Diving into the workflow screen notion a bit more, it really should be called a view model. But that name is taken. Google took it. That's fair. They've got definitely higher dibs than we do. It also turns out that our cohort on the iOS side was using view model to use something slightly the same, but also slightly different. People who've been learning about MVI have been hearing about view models and view state. Everybody uses view model to mean something that means like 90% the same, but it doesn't quite mean the same ever. So ours are workflow screens. Same idea. Each one of these workflow screens is a tuple, or really it's a triple. It has 3 bits of information that it carries. An immutable key to uniquely identify it, something useful for binding it to particular layout files and stuff like that. It has an observable of D, some kind of screen data type or view state if you're coming from MVI land. This is the stuff that updates over and over again to let us paint our views, and then it also carries a pointer to an event handler, something that implements an interface E that defines all of the events that make sense from this particular place in the app. So examples of screen objects are a login screen, an authorizing screen, a second factor screen, and a workflow, say. Looking inside one of those things, our login screen, it's got a key, might as well use its class name, that's convenient. It is only one event that it's actually worth thinking about on there. You hit the login button, good job. And as far as the screen data goes, all it's ever going to actually display that's not static, just part of the built-in layout, is maybe an error message that came in. Jump over for a second to a more interesting example of a workflow screen. This is actually from one of the screens in our app. And the screen data class here is more struct-like. There's the money due, there's the customer's name, the card number that was entered, and so on. The same old stuff that we always do. All right, so that's a workflow screen. What do we do with that to actually get it in front of our user? We have a kind of 3-part mechanism at the top of Android land or iOS land. If we were working on a command line version of this, we might have something simpler. We've got a container who is the kind of delegate responsible for listening to the workflow and what it thinks we should be prompting the user with right now. It has a friend called the view factory who knows how, given a particular workflow screen, to what layout to render for it. And it's got a view, a frame layout to stick stuff in, maybe with some transition effects. So we configure the factory with code as boring as this. When I see the login screen, I'm going to bind it to the login layout, and I'm going to instantiate this coordinator class to actually drive the whole thing. This is the first actual Android-specific code that we've actually run into on this screen. Any of the work to talk to the backend service or anything like that has been completely platform neutral. Coordinator is a little surprise. You don't know what that is or why I sprung that on you. Coordinator is a tiny little library that Logan Johnson introduced a year or so ago. It's kind of the platonic bare minimum of model view whatever that you might want to use on Android. A coordinator is a tiny little object that lets you know when a view has been attached to the window, lets you know when a view has been detached to the window, so that you can do things like on the attach method, do the usual view binding, or maybe make a butter knife call. Set up your click listener to take events from the click and push it back into that event handler that came into from the screen object. And finally, subscribe to the screen data and blat your stuff in, and then detach, throw it all away again. Similar in spirit to Google's workflow. No reason it couldn't actually be one. No reason for us to ship to that, but handy for that sort of thing. So we've got our workflow screens coming out. We've got our view displaying all those things. What about actually implementing a workflow? Why is this abstraction worth bothering with? What do they look like under the hood? We'll dive into a little code again. The authorization workflow probably starts off something like this. Remember, we have an in value and an out value. Our in value here is Kotlin unit, which is Kotlin for void, meaning I don't know, whatever, but we don't use null in Kotlin, we use unit because it won't actually blow up on us. And it's going to produce a string when we're done, the authorization key. It also implements these event interfaces. You remember that our workflow screens, each one was basically a contract saying, here's the data I'm going to render, here's the interface of events I will take back. The workflow, nine times out of 10, implements those event interfaces directly itself. So effectively, each workflow screen is a closure on the workflow. It's a filter on the workflow of a way for it to declare, when I'm in this particular state, here's exactly the data that I will render and nothing else. Here are exactly the events that I can receive and nothing else. View code, go crazy. You can't make any mistakes. The compiler won't let you. To actually implement this, we've probably got, say, a behavior subject that we're updating with the current workflow screen key, login screen key or whatever. We've got some subjects that we're keeping up to date with our actual screen data for each view that we might be showing. If we're in this particular implementation style, we're kind of keeping a buffer of the stuff that might need to be rendered. And then we share the actual screen observable. We implement that by keeping an eye on our screen key there and just mapping it. If it was the login screen, we'll return an instance of the login screen with its little message subject and a pointer back to this, the workflow, and so forth and so on. So this is just the workflow packaging itself up as masquerading as each of these individual screen personalities that it can take on. Then on the event handling side, we're implementing all of the event interfaces from these things, and for each one, I'm calling into this magical little state machine thing. What is a state machine? It is not a library, not open sourcing anything. It is just the usual state machine pattern. In this case, it's a little DSL that we whipped up literally in an afternoon. We give ourselves a few enums of the states that we might be in. We let ourselves define a few rules, like whenever we enter the authorizing state, we're going to update that screen key subject to the authorizing key. If it's the second factor prompt state that we're in, that's the one that we'll show. And we give ourselves a few transition rules. When I'm at the login prompt and I receive the submit login event from that event handling interface, well, then I'm going to shift over to the authorizing state. And as a side effect, I'm going to make a call to my authorization service. We won't drill into all of the code. If I'm in the authorizing state and an authorization response comes back from that service call that I kicked off on the previous line, then I'm going to transition back to the login prompt, provided that it was a login failure. And in the process of doing that, I'm actually going to render that error message to make sure that it gets pushed out to the login view, and so on. I'm not exaggerating when I said that this was actually an afternoon worth of coding to put together this little DSL. To do something similar and cleaner, I'd encourage you to look for this amazing little gist that Andy Matuszak put up a few months ago, maybe longer, about using Swift to write this style of finite state machine. It's very applicable to Kotlin as well. Again, I promise to put a link up on the screen if your photo doesn't come out quickly enough. There's no reason for anybody to open source a finite state machine library. They're just that easy to write. But everybody in this room really regrets that they haven't been writing finite state machines all along, because they make so much of this stuff so much easier. Let's see. I am getting a little light on time. We'll keep going. I want to do one more example of a style of doing workflow. If you've been using RxJava a lot, you probably noticed that I had a whole bunch of subjects in that first workflow, which is kind of a smell. It's a sign that you're at the boundary between imperative land and Rx land, and things aren't really as... It's a lot nicer if I could be deriving things from each other from one fundamental source rather than keeping all of these individual little buckets updated on the side. So I want to show a style of building a workflow that is more like that. In this case, we're doing that tic-tac-toe workflow we started again. We've got 4 screens where we prompt for the people who want to play a tic-tac-toe game, the screen where we're playing it, the screen where we confirm that you're quitting, which you notice is a dialogue. Ooh, fancy. And then finally, the results screen when we're done, subtly different. It says you won. Before going into the workflow, let's look at the view factory for that thing again. One thing that I like about this style of work, the difference between those layout-based screens and the alert dialog-based screen are the 6 letters layout or dialogue. From the point of view of the workflow and the workflow screen and everything else, completely agnostic about how things are choosing to be presented. It's just a question of whether I chose to instantiate a coordinator or this little dialogue factory thing that we've whipped up. The conversation, the flow of events is all the same. Also a nice characteristic here is I've got these 2 different states of the game. I'm either playing it or the game is over. I can use the same layout to drive both of those. I don't know about your MVP setup, but in our MVP setup, if I want the same view to be driven by different presenters, it's embarrassingly hard. I've got to find some way to kind of get the one thing to pull the other in different ways. With this sort of setup, with the coordinators and the screens, I just change 2 lines of configuration, make sure everything's shaped the right way, and it all just kind of works out. So the actual workflow itself, more of the same stuff about we're implementing all of our event handling. Instead of having 5 million behavior subjects, though, this time, what we have instead is a single observable derived from another observable. Remember that game runner that we started with, that brick that could take the tic-tac-toe moves and could spit out for you this nice immutable game state? So for my workflow, what all it's trying to do is put a UI on top of that. I'll base my, I'm going to subscribe to that game state. I'm going to prepend it with a kind of magical null object called the no game instance of game state so that I know that I haven't actually started running my game yet. I need a prompt for the input. And I've got one other little behavior subject has leaked in, which is a quitting subject, something that lets me know if the user is trying to get out of this game or not, and I need to prompt him about that. Then I'm going to use RxJava's combine latest, which is pretty much my favorite thing that RxJava ever did. I'm going to use that to keep an eye on whether the game state changes or whenever the quitting flag changes, and pass those into an update method that's going to decide what screen I should be showing. And this is, again, a simple little declarative, okay, were they trying to quit? If they were, then the quit screen is what we should be showing. Is the game state the magical null state? If it is, then I should be prompting for new game information. Otherwise, let's show the gameplay screen or the game over screen. These are kind of trivial examples, but where this starts to pay for itself is in stuff like somewhere in your app, like ours, you may well have a massive switch statement that's taking people through the decision tree of whether we're tipping, whether we're doing signatures, are we printing a ticket, are we doing this or the other, and lots of branching logic or whatever. In our case, that got scattered out to the 4 winds. This gives us a nice way to gather that all back into one place without having to gather so much stuff that's unrelated that is still unreadable. Let's see, very tight on time. I'm just going to buzz through really quickly how this all plays out in real life. We've got our moving parts here. Events are coming from our bricks. Based on that, our workflow state machine spits out a particular key. It's got our magical 3 bits of data that go to the container in its view factory. We read the key object, we inflate a view. We populate the view from the screen data, and we push events back into that event interface. But of course, those are all just aliases for the workflow. So after that little navigation step, what we really have is your ideal circular update flow, where a state that might be ticking in the bricks comes right up through an observable into the view, and the events from the view get pushed to the workflow back into the bricks. Occasionally, another screen state pops up. We spy in a new view, and the whole circular thing happens again. Finally, one last nice thing about the workflow model is that it composes really beautifully. I hope I said that they compose, because that was kind of the point. So just a workflow could have a cute little FSM inside of it, but there's also no reason a workflow couldn't be composed of other little workflows. Each state of it is the workflow that we're running at the moment. The auth workflow kicks off the game workflow, for example, which is actually exactly what I prototyped in December. This is not the faux Kotlin that I've been showing you that I pretend compiles. This is the stuff that actually worked in my prototype. I won't read into the details. The main point is that with this much code, I can set up a situation where when the auth workflow finishes, it kicks off the tic-tac-toe workflow. When the tic-tac-toe workflow kicks off, it kicks off another tic-tac-toe game, and I've got a big app built out of smaller parts. You don't have to kind of restrict yourselves to a situation where I've got one workflow that can be kicking off only one child workflow at a time. Like any other state machine type of system, I can have parallel workflows going on. So maybe I've got a status bar at the top of my screen that's kicking off things to be displayed. Maybe I've got a master detail section, another part of the screen where the master workflow is composed of the individual detail workflows that it's working through at the moment. It all just kind of scales very nicely without winding up with things that don't run nicely in isolation at the same time. So I honestly am out of time, so I'm going to skip the little tactics section that I had and go to the promised list of things at the end there. But I don't have code to put up yet. I will clean up the code that I put together to build the prototype and that we've been working from soon. I don't know if we'll get a library out of this or not, or just talk more about how nicely it's scaled for us. We're about 9 months into our 2-year project, and I'll be making some noise of some kind about how it all worked out. But so far, nobody's gone up in arms or carried torches or tried to burn the place down, so off to a good start. Stick around for questions. Thank you.